Geothermal energy is an important technology for decarbonizing the U.S. grid. Vervo, a startup company based in Houston, USA, announced that it was able to successfully generate electricity with geothermal energy, in the first generating station of its kind on a commercial scale, using hydraulic fracturing techniques and shale oil exploration innovations to produce carbon-neutral electricity. Although horizontal drilling allows oil producers to access new layers of fossil fuels, Vervo drills laterally in hot, porous rock heated by tectonic activity, according to Time.com. The company then pumps water through those rocks to generate steam and produce electricity. Currently, its project in northern Nevada can produce about 3.5 megawatts of electricity, or enough to power about 2,600 homes. When the plant is connected to the grid later this year, that electricity will be used to power Google's data centers and other Alphabet investment operations. This is reported by former oil employee, Tim Latimer, who began his career in the oil and gas sector, before co-founding Vervo in 2017. Tim Latimer spoke to Time about finding a way to use oil industry technology to benefit the planet, and his vision for the future of geothermal energy. Taking advantage of fossil fuel industry innovations. Former U.S. oil employee Tim Latimer argues that a series of fossil fuel industry innovations that helped spark the U.S. shale boom had the single largest impact on the course of global geopolitics, and the greatest impact on global politics and the world's biosphere. Tim Latimer noted that horizontal drilling and hydraulic fracturing have transformed the United States from being a net importer of fuels to an exporter. He explained that this transformation represents a reorganization of the global strategic landscape, and is currently appearing in the fleets of American oil and natural gas tankers that help circumvent the energy blockade imposed by Europe on Russia. Meanwhile, all this new, cheap fuel has helped perpetuate America's carbon addiction for years, with emerging renewable energy sources unable to compete with natural gas. Unlike solar and wind, which only generate electricity when the sun is shining or the wind is blowing, geothermal power plants can provide a continuous feed of electricity, which is crucial to balancing the grid. This geothermal energy currently represents about 0.4% of the world's electricity. United States. As in the U.S. hydraulic fracturing boom, Vervo's technology could make it possible to develop geothermal plants in many areas that were not previously financially profitable, Tim Latimer said. He explained that this change could help increase geothermal energy as an important technology in removing carbon from the U.S. grid. How Vervo technology works. Geothermal electricity generation has been around for more than 100 years, said former U.S. oil employee Tim Latimer. The first geothermal power plant was built in Italy at the beginning of the last century. He added, all types of geothermal energy work in the same way. The company drills into high-temperature layers of the earth, then produces hot water or steam from the wells it drills, then captures that on the surface to generate electricity. He pointed out that stations are being built all over the world, and that they represent a large part of the electricity mix in countries such as Iceland, New Zealand, and Kenya. Companies have traditionally had to take advantage of hot, shallow, productive natural basins to be cost-effective, he noted, hinting that those sites were exploited decades ago, had to drill deeper into less hot locations and less productive wells, and technology hasn't really kept up. The reason geothermal energy has not expanded is that once these geological hotspots were selected and attempted to move elsewhere, the technology did not exist to make them cost-effective, according to Time.com. He added, traditionally, you could drill simple vertical wells, and the water would flow between the injection wells and the production wells. What's new about our site is that we drilled about 8,000 feet, 2,438.4 meters, and then turned around and drilled horizontally for 4,000 feet, 1,219.2 meters. Then we move water from one horizontal well to the next across several hundred feet in that high-temperature rock, 8,000 feet, 2,438.4 meters, below our feet, and that solves some of those economic challenges, and allows us to go deeper and continue to making the economy successful. Harmonizing oil and gas technology with geothermal energy. Our geological requirements are very different, explained former U.S. oil employee Tim Latimer. In the United States, over 100,000 horizontal oil and gas wells have been drilled, but generally, those wells are in shallower locations where the rock is softer, not as hot. So, it took a lot of work to be able to adapt the equipment, because the temperature of our wells is much higher. And the project we did here was about 400 degrees Fahrenheit, 204.44 degrees Celsius, and we are drilling through granite, and that is a much harder rock, he added. New technology for drilling through rocks. Former U.S. oil employee Tim Latimer said some of the equipment and technology were sophisticated tools, such as hard surface drill bits, motors, and electronics designed to handle high temperatures. He explained, some of them are just advanced technologies, and one of the things we pushed forward was the method of pumping fluids down through drilling, which cools your drilling system more efficiently than the oil and gas process. Current Vervo projects. Our current projects are in states like Utah and Nevada, which have natural geology that is suitable for geothermal energy, where we can still drill relatively shallow wells and reach high rock temperatures, said former U.S. oil employee Tim Latimer. We just started there first because it's the cheapest option, he added. Basically, there's literally an unlimited amount of geothermal energy. He continued, we believe that using current technology, it may be cost-effective to drill to a depth of about 4,000 meters, more than 13,100 feet.